Today we are going to discuss about a damped free vibration. So in the last presentation we have seen undamped free vibration. So here we are going to discuss about damped free vibration. So this is the model for damped free vibration. If it is undamped, this damper will not be there. So this is a damper. Only spring and mass will be there. Since it is a damped vibration, so we have one damper also. A small displacement disturbance x is given and the force is removed. Since it is free vibration, force is removed. So at this particular position, it will have acceleration. It will have some deflection x. So spring is also deflected by distance x. So it will have some restoring force. That is, we can say it is k into x. That is a restoring force. Since it is deflected by distance x and the stiffness is k into x is a restoring force. And inertia force. Since it is in acceleration, the inertia force is mass into acceleration. So mass into d square x by dt square. So here we have the damper. So the damper, what is damper? Damper is it gives resistive force for vibration. What is the unit of damping coefficient? That is resistive force offered to vibration per unit velocity. Per unit velocity. So if you want to find the force, then you have to find c into velocity, dx by dt. Dx by dt. So now, if you write the equilibrium equation, then this plus this is equal to 0. So this is the equilibrium equation. So now let us derive expression for different terms in damped free vibration. So this is a system. This is a system. So now if you write the equilibrium equation is m into d square x by dt square. This is inertia force plus the resistive force in damper, that is c. This is resistive force per unit velocity. Multiply by velocity will give the force dx by dt plus stiffness of the spring multiplied by deflection. That will give the force. Since it is in equilibrium, this must be equal to 0. This must be equal to 0. So this is the equation. So this is a second order differential equation. You can, the solution for this one is x is equal to e power st. So this is a form of solution. Now you find dx by dt for this. If you find dx by dt, what will come? Dx by dt is equal to s into e power st. Similarly, d square x by dt square is equal to s square into est. Right? So differentiation of e power st is equal to e power st into multiplied by s. So you will get like this. If you substitute in this equation, finally you will get, instead of d square x by dt square, you have to substitute s square into est. So in all the equation you will get est. If you cancel this, you will get an equation like this: m into s square plus c into s plus k is equal to 0. So this is the equation you will get. If you find the solution for this equation, is a quadratic equation. So s is equal to minus b plus or minus root of b square minus 4ac by 2. So this is the equation. By if you substitute in this equation, you will get s is equal to minus s is equal to minus c by 2m plus or minus root of c by 2m the whole square minus k by m. You will get this. So if you put plus, that is s1. If you put plus, that is 1. If you put minus, that is s2. So this is s1 comma 2. There are two solutions. If you put plus, s1. If you put minus, s2. So there are two solutions for this. So now what we are going to do is, I am going to take one condition. That is, if the term within the root is equal to 0. If the term within the root is equal to 0, then what is then this must be equal to this. This must be equal to this. So this condition is known as critical damping condition. Critical damping condition. We will discuss what is critical damping condition later. Okay, I am assuming C by 2m the whole square is equal to k by m. If I assume like this, this will be 0. This term will be 0. From this, you can find the value of C. If you find the value of C, you will get 2m omega n. So this is what you will get. So at this condition, the damping coefficient C is equal to Cc. We take it as Cc. C is equal to Cc. So this is known as critical damping coefficient. This is one of the important relation. Critical damping coefficient. Now what I am going to do is C by 2m. I am going to replace this C by 2m. So C by 2m can be written like this. C by 2m, that is equal to C by 2m. I am multiplying and dividing by omega n. Omega n, omega n. 2m omega n. What is 2m omega n? That is Cc. That is Cc. Right? Cc. So you will get C by Cc multiplied by omega n. Multiplied by omega n. So this is Cc. C by Cc, I am assuming it is, I am taking this as a psi. C by Cc is known as damping factor. C is damping coefficient, Cc is critical damping coefficient, and C by Cc is equal to damping factor. Damping factor into omega n. So now, so instead of this, I can use this. I can use this. Similarly, k by m. What is k by m? Root of k by m is equal to omega n. So k by m is equal to omega n square. Omega n square. So now I have the value of k by m in terms of omega n square. Similarly, C by 2m is equal to, I am getting psi into omega n. I am substituting in this equation. So finally, I will get S1, 2 is equal to minus psi plus or minus root of psi square minus 1 within bracket omega n. So this is the value I will get. Now I am going to write the value of the x in terms of 3 conditions. First, I am taking one condition, that is psi. Psi is greater than 1. Psi is greater than 1. See, in this equation, if I take psi is greater than 1, this will be positive. This will be positive. So this condition is known as over damping. Over damping. Okay? Over damping. So if I assume that, then what is the value of x? You will get, already we know what we assumed, x is equal to e power st. Here we are getting two constant, s is s1, s2. We have two values. Then I can write, then x is equal to a into e power s1t. A into e power s1t plus a to b into e power s2t. The same equation, since we have two values, I can write the equation like this. So here, if you substitute the s1 and s2, you will get like this. A into e power, what is the value of s1? You take minus first. That is minus tau into psi into minus root of psi square minus 1 into omega n. Into omega n plus b into e power minus psi plus root of psi square minus 1 into omega n. So this is one equation. When I assume psi is greater than 1, I will get the x value is this. This is a x value. I will get one equation. If I assume psi is equal to 1, then in the s1, s2, this value will become 0. Then I will get x is equal to a into e power minus psi into omega n t plus b into e power minus psi omega n t. So if I assume tau is psi is equal to 1, this is known as critical damping. Critical damping. So this is over damping, this is critical damping when psi is equal to 1. So you will get this equation. You will get this equation. Similarly, I am assuming tau is less than 1. Psi is less than 1. This is known as under damping. Under damping condition. So in this condition, if this is psi is less than 1, so within the root I will get minus. So then what I am going to do is, if it get minus, so that will become an imaginary number. Then I am rewriting like this: yes 1 comma 2, yes 1 comma 2 minus psi plus or minus within the root. I am taking minus 1 outside. Then it will come 1 minus psi square. What is minus 1? It is I square. Then I can take minus 1 is equal to I square. Then I can take minus psi plus or minus. I can take I outside. 1 minus psi square. So this is a S1 comma S2. Now you substitute in this equation. X is equal to, what you will get is x is equal to a into e power minus psi plus let us take this is minus or plus I into within the root 1 minus psi square into omega n t. Here also you will get t. Here also you will get t. You will get t. Then plus b into e power minus I. Here you have to take minus I into root of 1 minus psi square within bracket omega n into t. So there are two equations. So now you reduce this equation, you will get x is equal to e power minus psi omega n t within bracket capital X into sin omega d plus t, omega d plus psi, omega d t into psi. So you will get the equation like this. So now we got 3 here. We have omega n only in this equation, but we are taking omega d. What is omega d? It's a damped circular frequency. Omega n is equal to circular frequency. This is omega d is damped circular frequency. That is equal to root of 1 minus psi square into omega n So now there are 3 x values. When psi is greater than 1, we have one that what is x is a displacement. It is a displacement. Similarly, when psi is equal to 1, we have this equation. When psi is less than 1, we have this equation. There are 3 equations we got. Here we found 3 important expressions. What are the expressions? The first expression is displacement equation for under damping. That is x is equal to e power minus psi omega n t into within bracket capital X into sin omega dt plus psi. So this is x equation. So another equation what we got is critical damping coefficient. C is equal to 2m omega n. This is another equation. Then psi is equal to c by cc. And final equation is omega d is equal to root of 1 minus psi square into omega n. So these are all the 4 important expressions we have derived from this one. So I was telling about, So these are the 4 important expressions we required for calculation purpose. So in this, I have assumed 3 conditions. One is psi is greater than 1, that is over damping. Psi is equal to 1, that is critical damping. And psi is less than 1, that is under damping. So there are 3 conditions we assumed. For that we have x value. Here also we have x value. Here also we have x value. If you draw this graph, the display x, what is x? It is a displacement. It is a amplitude of vibration. So if you draw a graph for this as a function of time, how you will get? See, you can see this is a graph. This is a graph for under, critical, and over damping conditions. We have 3 x values. We have 3 x values. If you draw in terms of graph, you will get like this. If it is under damping, this is a graph. This is a, if it is under damping, this is a graph. It is amplitude of, this is amplitude of vibration. This is amplitude of vibration. This is a amplitude of vibration, right? This is gradually it is reducing. Gradually it is reducing. Slowly it is reducing. This is under damping condition. If you draw, this is x, this is x, this is time. If you draw the graph, you will get like this. If it is critical damping, you see, this is a curve for critical damping. This is a curve for critical damping. When you displace the body to some position and you leave it, it is slowly coming to mean. That's all. It is not executing any vibration. So in case of that is critical damping. Over damping means you displace the body to this position and leave it. It is taking infinite time to come to mean position. So that is over damping. Damping, the resistance is too much. The resistance is too much. So when you displace the body to this position, it is not coming back to mean. It taking infinite time. If it is critical damping, it is straight away. It is coming to the over a period of time. It is coming to the mean. But in case of under damping, it executes vibration. It is when it is displaced and leave the body, it is going below the mean. It is coming to mean. Then it is going below the mean. Then above the mean. Below the mean, above the mean. It executes a cycle. So if the damping is under, then only it will execute vibration. If it is critical damping or over damping, there will not be any vibration at all. So our interest is to study about only under damping. So because we are studying about vibration, in under damping only, there will be a vibration. It executes a vibration. So we have to study only about under damping, right? So this is a graph for different damping. If damping is very less, so it is what is meant by damping is very less. That is resistive force is very less. Resistive force vibration is very less. So the amplitude of vibration is more. It is slowly coming to rest. It takes more time to come to rest. If you increase the damping, the amplitude of vibration is slightly less, and it takes lesser time to come to rest. That is the diode of vibration. So as you increase the psi value, that is damping factor, so the vibration will be stopped in short period. So when it is 1, we are talking about 0.1, 0.25, 0.5, 0.7. When psi is equal to 1, what is, that's a critical damping. That is a critical damping. It will not execute any cycle. Straight away it come to mean. If it is too much over damping, it will take long time to come to mean. So we need not study about the over damping and critical damping. Whenever the psi value is more than 1, that is over damping. Equal to 1, that is critical damping. Less than 1, that is under damping. In under damping only, vibration will be there. So as damping factor is very less, it will take more time to stop. So that's what you can understand from damping, right? There is no damping at all. No damping at all. The curve will be like this. If there is a damping, under damping, it will be like this. It will be slowly dying out. Here, there is no damping. There is no resistance force to the vibration. So it is continuously vibrating. So such condition is not existing in nature. So there will be a slight amount of vibration. So over a period of it will stop. But here, if you assume that there is no damping, so that's what we discussed earlier. That is another undamped vibration. Undamped vibration. If it is undamped, it will continuously vibrating. It will not stop. If there is a damping, it will stop. So there's a difference between the undamped vibration and damped vibration, right? So now we are going to discuss about logarithmic decrement. Logarithmic decrement. So what is logarithmic decrement? See, in underdamping, in first cycle, the amplitude of vibration is x1. In the second cycle, amplitude of vibration is x2. In the third one, it is x3. x1, x2, and x3. So in this case, what is logarithmic decrement is? It is x1 by x2. Log of x1 by x2 is known as logarithmic decrement. It is denoted by delta. What is logarithmic decrement? It is log of ratio between the two consecutive cycles. That is denoted by delta. Logarithmic decrement is a logarithm of ratio of two consecutive vibrations, two consecutive cycles. That is denoted by delta. To calculate delta, there is an equation we have, that is 2 pi psi into root of 1 minus psi square. So this is the equation for logarithmic decrement. Here, what is psi? That psi is equal to C by Cc. What is Cc? Cc is equal to critical damping coefficient. This is damping coefficient. How to find Cc? Cc is equal to 2m omega n. Right? So these are all the relations. Logarithmic decrement, the logarithm of ratio between two consecutive cycles. Now we are going to solve problems. Okay, this problem you see, an instrument vibrates with a frequency of 1 Hz. Frequency of 1 Hz, there is no damping. There is no damping. Then what is this? This is Fn. This is known as Fn. The Fn is equal to frequency of natural vibration. Frequency of natural vibration means with no damping. When there is no damping, what is the frequency of vibration? That is known as natural frequency, Fn. What is that? This is 1 Hz, right? When the damping is provided, the frequency of damped vibration was 0.9 Hz. So this we can take Fd. Fd is equal to 0.9 Hz. When there is no damping, frequency is 1 Hz. When there is a damping, frequency is 0.9 Hz. 0.9 Hz. So you are asked to find damping factor and logarithmic decrement. These are the two things we have to calculate. What is damping factor? Damping factor already have studied, that is psi. Psi is equal to C by Cc. So that's what we have studied. What is logarithmic decrement? That is delta. What is delta? Delta is equal to log of x1 by x2. That is a ratio of two consecutive amplitudes. That is equal to 2 pi psi divided by root of 1 minus psi square. So these are the two equations. Now first you have to find the psi. How to find the psi? That is damping factor. Now Fn is given, Fd is given. Already we have seen a relation between the omega n and omega d. What is the relation? Omega d is equal to root of 1 minus psi square into omega n. This equation we know. So since we know Fd, you can find the value of omega d. Since we have Fn value, you can find the value of omega n. So you can only unknown is psi. You can find the value of psi, right? So how to calculate what is the relation between Fn and omega n? We know that Fn is equal to omega n by 2 pi. Similarly, what is Fd? Fd is equal to omega d by 2 pi. This is the equation. We know the value of Fn. You substitute the value of Fn and find the value of omega n. Similarly, you substitute the value of omega Fd and find the value of omega d. Find the value of omega d. So what is the value of omega n? Omega n is equal to 6.284 radian per second. What is the value of omega d? Omega d is equal to 5.66. 5.66 radian per second. You substitute in this equation. That is omega d is equal to 5.66 equal to root of 1 minus psi square into omega n. Omega n is equal to 6.284. From this, you can find the value of psi. Psi is equal to 0.436. 0.436. From this, what do you understand? This is a underdamped vibration. Underdamped vibration. If the value of psi is less than 1, that is underdamped vibration. If psi is equal to 0, that is undamped vibration. This is underdamped vibration. This is if 0 means, and there is no damping at all. No damping at all. Now we can find the value of delta. So here delta is equal to, you know the value of psi. You substitute the value of psi, 2 pi into psi. Psi is equal to 0.436 divided by root of 1 minus 4.436 square. So it will give the value of delta. It is equal to 3.04. Right? You can find the value of psi and delta this way. So now another problem. Yeah. A measurements on mechanical vibration shows mass is 8 kg. Mass is 8 kg. Stiffness is 5.4 Newton meter. So mass is equal to 8 kg. K stiffness is equal to 5.4 Newton per millimeter. So you convert this into meter. So millimeter, it is in denominator. If you convert this into meter, 10 power minus 3. So if it goes up, it will be you multiply with this don't with 1000. So 5400 Newton per meter. Newton per meter. That system, and force of 40 Newton, which has velocity of 1 meter per second. The resistive force is 40 Newton. What is this? This is C. C is equal to 40 Newton meter per second. We have to find the critical damping coefficient, damping factor, logarithmic decrement, and ratio of two consecutive amplitudes. So these are all the things you have to calculate, right? The first step is finding the critical damping coefficient, right? So to find the critical damping coefficient, what you have to do? We want Cc. Cc is equal to what? Cc is equal to 2m omega n. So in this equation, 2m, omega n is not given here, but you know what is omega n? What is omega n? Is equal to root of k by m. You substitute the values. 2 into m is equal to 8 into root of k by m. K is equal to 5,400 Newton per meter. You substitute k by m. M is equal to 8 kg. So this will give the value of Cc, right? The value of Cc is equal to 416 Newton meter per second. This will be the value of Cc. Then you calculate the damping factor. What is damping factor? Damping factor. What is the equation for damping factor? That is psi. Psi is the damping factor. That is C by Cc. Already in the problem, C is given. C is given in the problem. It is 40. So 40 divided by 416. 416. So this will give the value of psi. Psi is equal to 0.436. 0.436. And logarithmic decrement. Logarithmic decrement, that is delta. How to find the value of delta? Logarithmic decrement, we have equation 2 pi psi divided by root of psi 1 minus psi square. 1 minus psi square. 2 pi, what is the value of psi? It is 0.436 divided by root of 1 minus 0.436 the whole square. So it will give the value of delta. It is psi is equal to, here it is wrongly given. I have given wrongly. It is 0.096. So this is a value. So this is 0.096. This is 0.096. It is wrongly entered. So this will give the value of delta. Delta is equal to 0.6. 0.6. Now you can find the ratio of two consecutive amplitude. What is that? It is x1 by x2. So that is, so we know that log of x1 by x2 is equal to delta. What's the value of delta? Delta is equal to 0.6. That we know. So from this, you will be able to find the x1 by x2 value. So here, if you take e power, if you take e power log x1 by x2 is equal to x1 by x2. x1 by x2, that is equal to e power 0.6. How much it is? It is 1.82. 1.82. This is the way you can calculate. The last problem is So in this problem, it is given the mass of single degree damped vibration system is 7.5 kg. What is the mass? Mass is equal to 7.5 kg. Makes 24 free oscillation in 14 seconds. 24 free oscillations per free second. From that, what is Fn? Fn is equal to number of oscillations per second. So 24 divided by 14. 24 divided by 14. So that will be equal to 1.7. 1.7. So Fn is not directly given. Here it is given 24 free oscillations in 14 seconds. So oscillations by time you will give the Fn. Then it is given the amplitude of vibrations reduces to 0.2. Amplitude of vibration reduces to 0.2 of initial value after 5 oscillations. After 5 oscillations. So that means, so it is vibrating like this. It is vibrating like this. Right. This is first cycle. This is second cycle. This is third cycle. This is fourth cycle. This is fifth cycle. This is sixth cycle. There are 6 cycles. This is x1. This is x2. This is x3. This is x4. This is x5. This is x6. 5 cycles. 6 cycles. It is given that 1, 2, 3, 4. 1, 2, 3, 4, 5. So here x1, x2, x3. Okay. So here what is given? The amplitude of vibration reduces to 0.25 of initial value after 5 oscillations. After 5 oscillations. So then you have to take, what you have to take is 5 oscillations. That is, this is first one, x1 by x2. So this is x2 by x3. Similarly, x3 by x4, x4 by x5, and xy by x6. This is 1, 2, 3, 4, 5. So here what? So what it is given is x1 is x6 is equal to how much? It is 0.25 times initial value. What is the initial value? 0.25 times initial value. 0.25 times initial value. So x1 by x6 is equal to x1 by x6 is equal to how much it is? It is 1 by 0.25. Am I right? x6, that is the amplitude of vibrations reduces to 0.25 times of initial value. That is x is equal to 0.25 times x1. That is x1 by x2 is equal to this value. So now we can write this also x1 by x6. x1 by x6, I am writing like this. If you cancel x2, x2, x3, x3, x4, x4, x5, x5, you will get x1 by x6. x1 by x6, that is equal to divided by 0.25. From this, already we know that the ratio of two consecutive amplitudes are constant. That is x1 by x2 is equal to x2 by x3 is equal to x4 by x is equal to x4 by x5 is equal to x5 by x6. Then you can write this equation x1 by x2 the whole power 5 is equal to 1 by 0.25. From this, we can calculate x1 by x2. x1 by x2 is equal to 1 by 0.25 the power 1 by 5. What is the value of x1 by x2? It is equal to 1.32. So from this you can find the logarithmic decrement. Logarithmic decrement. What is logarithmic decrement? That is delta is equal to log of x1 by x2. What is x1 by x2? This value. So log of 1.32. From this, you can find the value of delta. It is 0.28. So that is logarithmic decrement. Then damping factor. What is damping factor? That is psi. Psi is equal to damping factor. So what is psi? Psi is equal to C by Cc. So how to find the value of Cc? That we have to find. So now we have the value of delta. So there's a relation between delta and damping factor. Delta is equal to 2 pi psi into divided by root of 1 minus psi square. So from this you substitute the value of delta, that is 0.28, and find the value of psi. So psi is equal to 0.045. So this is the way you have to solve this one.